This is number 3 from the 2007 exam. Okay, so we have this table of values with two different functions, f of x and g of x, and their derivatives. We're told that our functions are differentiable for all real numbers. G is strictly increasing, so I'm going to make a note that g prime must be positive. And then the table gives values of the functions of their first functions and of their first derivatives at selected values of x. And then we've got this definition for h of x. So for part A, we need to explain why there must be a value r, where r is between 1 and 3, such that h of r is equal to negative 5. Well, let's first find h of 1. So g of 1 is equal to 2. So now we've got f of 2 minus 6, and f of 2, here's 2, is equal to 9. So we have 9 minus 6, which is equal to 3. All right, let's see the function value at the other end of our interval. So h of 3 is f of g of 3 minus 6. G of 3, here's g of 3 is equal to 4. And f of 4, here's f of x, f of 4 is equal to negative 1. So we've got negative 1 minus 6, which is equal to negative 7. So what this means is that on our interval from 1 to 3, our function takes on values from 3 to negative 7, which would include our negative 5. So we should say, well, this only happens if h is continuous. Now we know f and g are differentiable, which means that f and g are continuous, which means that h must be continuous. So we can say since h is continuous on 1, 3, and since the value they're talking about, that negative 5, is between h of 3 and h of 1, there must be some value r in our interval from 1 to 3 such that h of r is equal to negative 5. And this is by the intermediate value theorem. And now for part B, we need to explain why there must be a c in the same interval such that h prime of c is equal to negative 5. So they're talking about the derivative. So I think I want to take a look at the secant line. That's h of 3 minus h of 1 over 3 minus 1. Now we already found those values in part A, so this is negative 7 minus 3 over 2. So negative 10 over 2 is negative 5. So here we have the slope of the secant is negative 5. So by the mean value theorem, someplace the derivative should be equal to negative 5. So we should say since h is continuous and differentiable, there exists some c in 1, 3 such that, what function are we looking at? H prime of c is equal to negative 5, and that's by the mean value theorem. Part C, we are given another function, w, and we have to find the value of w prime at 3. So I'm going to try to fit this right in here. Part C, we want w prime. Well, w prime is the derivative of this integral here. So we need to use the chain rule and have f of g of x times g prime of x. So at 3, w prime of 3 is f of g of 3, g prime of 3. So g of 3 is 4, and g prime of 3 is 2. So g of 3 is 4, and g prime of 3 is 2. And f of 4, back to the top, here is f of 4 is negative 1. So we've got negative 1 times 2, which is negative 2. So w prime of 3 is equal to negative 2. All right, last part over here. Whoops, let's undo that line. Last part, we are looking at the inverse of g, and we need to write an equation for the line tangent to the inverse at x equals 2. So part D, we know that on our inverse, x is equal to 2. So we should look on G for where G is equal to 2. So here we have the point 1, 2 on G, which means that on G inverse, we'd have the point 2, comma 1. So back down here, our y value should be 1. But now we need the slope. Well, we know that to find the derivative of the inverse, we do 1 over the derivative of the inverse. So we get 1 over g prime. We know that g inverse at 2 is 1. And g prime of 1, back up again, here's g prime of 1 is equal to 5. So the slope is 1/5. So we come here, and our tangent line is y minus 1 equals 1/5 times x minus 2.